Okay, this is the first video. It is filtering and sorting. So what we're going to start with is bringing in the dependencies. So import dependencies, import pandas as the alias PD, import numpy as np. I'm not sure if we use numpy, but you never know. And then import warnings dot simple filter, and we're going to ignore the warnings. Let's see if it works. It does. So now let's import the data set. So it's sales data, and we're getting it from an Excel file. So pd.read Excel, and it's called sales data set dot XLSX. Let's check to see if it worked. Great, came through. You can see a couple of different fields here: customer group, store name, the gross sales, and we just do the first 5 here with head. Okay, so let's just check to see how big this data set is. Okay, it's 13,000, not that big. Let's check to see the nulls. Dot is null sum. Okay, a few nulls here. So campaign ID, which means not all sales are connected to a campaign, which is fine, but some missing product names that we'd need to get from a product table with the product ID, but we won't do it in this video. Okay, so we can also do the opposite of this. So there is null, we can also say not null, and then we see the reverse. So campaign ID is less and product is less than the total data set, the number of rows. Okay, so let's start to do some filtering. So let's have a look at the different customer groups. So let's say let's print the sales data customer group, and we'll check the unique of that. Unique. Okay, so there's 4. A market that's supermarket, market, not so supermarket. So this is fake data. This is what I've created. And you can feel free to use this data set to use and play around with yourself. So now let's create a subset of the main data set. Let's just use supermarket. So we'll go we'll create a variable supermarket equals sales data. This is the first filter, sales data customer group. Whoa. Wrong one. Customer group equals supermarket. Let's see. Okay, so now we have all the supermarket, as we've just saved it into a filtered sales data set. It's saying only give us the supermarket customer group and hold in this variable. So we've got 5,000 rows now. Now let's work our way down. So let's say the business says, well, how many stores does supermarket have? Well, we can go supermarket store name, and we check the number of unique, 19, and we can check the names of those. So again, fake data. This is just suburbs in Sydney starting with B for the stores. And so let's say now that we want another subset of, let's say, supermarket and Bardia. So how do we achieve that? So let's do another filter. So supermarket and Bardia equals, and from the original data set we'll filter it from. So we'll go sales data sales data. The first one is the customer group equals supermarket. And what we might do is we might put this in brackets and sales data, store name equals Bardia. Okay, let's see what that returns. That's one small error. Okay, so now we have supermarket Bardia, and let's say that we want to get down even further. So let's say we want supermarket Bardia and Salak as the product. So let's do that. So supermarket and Salak. So let's start again from the sales data. Sales data. Customer group equals supermarket. And we'll put this in brackets. We won't make the same mistake we did last time. And sales data, store name equals what did we use before? Bardia equals Bardia, and sales data product is what we decided on, and we said it was Salak, whatever that is. So let's, okay, one entry, interesting. Okay, so that's how you filter with different conditions, similar to how you would do it in Excel. So let's look at all the different products within the main data set. So how many different products are there? That's a good question. Sales data product dot, let's say, number of unique, 567 different products. Okay, interesting. Let's say that out of these products, how many have the word apple in it? So we'll say apples equals sales data, sales data product dot string dot contains apple. I'll make it a lowercase. Apple NA equals false. Show me the products dot unique. Let's see. Okay, so all these have the word, even pineapple has apple in it. Okay, so let's try a different way of doing this. So let's say that we only want 3 of these apples, and we've just decided as a business that we're going to track them. So it's going to be, let's say, emu apples, and let's say black apple, and let's say sugar apple, just random. Okay, so you put that into a list, and you call it apples to track. I don't know, make that up. So let's go then, let's say tracking equals sales data product, and this time we're going to pass in the list above with is in apples to tracking. Let's see. Okay, so now we've got sugar apple, black apple, and I would imagine that emu apple is in there somewhere else. Okay. Then let's say, okay, well, we're tracking these. Can you quickly give me a list of stores that sell it? Sure. So we'll go tracking dot store name, and we say unique, and these are the stores that are selling the tracked the tracked apples. Okay, so let's say that we want to look at all apples, but we only want to see products that end in the text apple. So we'll say ends with apple, sales data product, and this time it's string dot contains space apple $, then NA equals false, ends with apple product. Let's have a look. Unique. Okay, so all these end in space apple. That's pretty handy. Let's say we want it to start with apple, so we can do something similar. Whoa. Starts with apple, so all we need to do is just put the symbol here, and oh, none. So let's choose another one. Let's say it starts with sugar. So put sugar in here. Only sugar apple. Let's try another one. Say black. Black mulberry, blackberry, of course, blackcurrant. Yep. So that's how you would do that. Okay, so now let's do some filtering for the different columns. So let's say that the first way of doing it is sales data passing a list. So we want, say, customer group. We want store name, and we want gross sales, and then we've got that. So this is our original data set, but only considering these three. But what I like to do is keep certain columns and then keep a list like this and pass it in. So doing something like, let me think, sales equals refined sales equals sales data, and then we'll say keep columns. Same thing again. And then let's say that you had 10 columns and you wanted to keep 9, so you didn't feel the need to maintain all 9 here, you just wanted to drop one. So you could take this, and let's say we drop the gross sales. So let's go drop, and we say gross sales, and access equals 1. And let's see how it looks now, and then we've dropped gross sales. So maybe we can also filter by data types. So we can say only numbers, and let's go sales data dot select underscore D types. Oops, include, and some numbers is float 64 and int 64. Let's have a look at that. So the column's only containing numbers, and let's see it as strings or objects. So only objects. So this time we'll just include object. Only objects. So there we go. We don't have any numbers in this one, just objects or strings. Okay, so now we want to filter by dates. So let's just create a quick copy of this data set. So we'll say sales data dates equals sales data, and we take the sales data dates date, and we need to turn this into a date time object. So we go ed dot to, and let me just remind myself, to date time, obviously, to date time. So that should work. And then if we go sales, if we have a look at that, so these look obviously a lot different compared to these strings. And then if we set that as the index, so if we go sales data dates dot set index, and we want to set it as date, in place equals true, and then let's just have a quick look at that. So you can see that they're in bold. So if you compare that to this one here, it's just numbers. And then from here, we can actually filter dates now. So sales data dates, and then we have to go year. So 2000, and let's say we want to filter 2019 01 to 31 colon 2020 01 31, and what does that return? That returns now a subset of the original database within this date time period. Okay. So now let's do a couple of advanced examples, or semi-advanced. So let's try and find negative sales. So negative data, sales data negative, and we say sales data, and we do gross sales. And if it's less than 0, then it must be negative. So let's have a look. And it is. There's three rows, positive units and negative gross sales. That's not great to see in a data set, but we'll keep going. So let's have a look at below average. So below average is sales data. You can see the repetition here. Gross sales is greater than sales data gross sales. We set the average, so we apply the mean. And to see this, let's also values, and we'll sort it by gross sales. And in place equals true, and let's go highest to lowest. So let's go ascending equals false. Print. Alright, so this is everything above the average. So 9,000, so this is the highest obviously, and then the lowest is, so I guess the average is somewhere under this number here. Okay, so now let's try something a bit more advanced again. Let's create a function to filter it with, to filter our data set with. So let's try and find berries. So berries, so I like berries. If it contains berries in X, return true, else return false. Berries equals sales data, and we look for it in product group, because it's here, and product group, and then we apply our function, which is any berries. Then if we show that, we have all our berries. And then there's slice notation. I don't normally use slice notation, but just a couple of examples. So it's just sales data, let's say the top 3 rows. So that's the top 3 rows. Let's say the bottom row. I believe that is, that's right, the bottom of the rows is on the left of the colon, so -1, and that's the bottom row. Alright, thanks for watching.